Hi, welcome to a complete course in calculus. This is Tadesse. In this tutorial, we'll see how to graph a function. So in particular, I have an example here which says f of x equal to 4x over x squared minus 1. So to graph, I'm going to show you the procedures for graphing any function. First, we need to find what is called the domain, and then we'll go to finding the intercepts, and then we'll find the asymptote, then the interval where f is increasing, decreasing, if we have any local extrema, and then we'll see where the function is concave up and concave down. So let's see one by one. So the domain. So for rational function, the domain is anything except the denominator will be 0. So as you can see, the denominator is x squared minus 1. This will be 0 if x squared equal to 1. So what does that mean? X equal to plus or minus 1. So the domain will be anything, any real number except plus or minus 1. Good. So what is the x-intercept? X-intercept means you just plug y equal to 0. So if it is y, which is f of x is 0, so that will give me 4x over x squared minus 1. So a fraction is 0 means the numerator must be 0. So 4x equal to 0. So if 4x equal to 0, x must be what? 0. So the x-intercept is 0, 0. So similarly, y-intercept means x must be 0. If x equal to 0, you can see that y will be 4 times 0 divided by 0 squared minus 1, which is 0. So similarly, the y-intercept is 0, 0. So how do I find the vertical asymptote and horizontal asymptote? For a vertical asymptote, first you need to find the candidate. The candidate is the 0 of the denominator. So I'll just find the limit of 4x over x squared minus 1 as x approaches to 1. And then this limit is, you see, as x approaches to 1, the denominator is 0, but the numerator is a constant, 4 times 1, or, number close to 1. So this guy goes to either infinity, if you are already going from the right, or it goes to minus infinity. So in both cases, it goes to plus, it is unbounded. So x equal to 1 is a vertical asymptote. So similarly, you can show that the limit of 4x over x squared minus 1 as x approaches to negative 1, either from the right or from the left, it goes to plus or minus infinity. So what that means? X equal to negative 1 is another vertical asymptote. So how do you find the horizontal asymptote? You just simply find the limit of the function as x approaches to plus infinity and minus infinity, which we call it the end behavior, right? So this is just a rational function. So if you want to find limit at infinity, just divide the numerator and the denominator by the term with the highest exponent, in this case x squared. So that would give you limit of 4x over x squared divided by x squared over x squared minus 1 over x squared. X goes to plus or minus infinity. So this will give me limit of 4 over x over 1 minus 1 over x squared. X goes to plus or minus infinity. So in both cases, this guy goes to 0, this guy goes to 0. So the answer is 0. So what does that mean? Y equal to 0 is the horizontal asymptote. So I'm done with the asymptotes. Now let's go to critical number. So to find the critical number, definitely you know that I have to find the derivative. So what is the derivative of this guy? It's rational function, right? So I can use the quotient rule. So it will be 4 times x squared minus 1 minus 4x times the derivative of x squared minus 1, which is 2x, everything divided by x squared minus 1 squared. Now, you can simplify the numerator. When you simplify the numerator, it will be negative 4 times x squared plus 1 divided by x squared minus 1 squared. So now, this derivative will never ever be equal to 0, never, because the numerator is x squared plus 1. And it will be f prime at x will be does not exist if x equal to plus or minus 1. But this guy is not in the domain. So my conclusion will be no critical number. Okay. Now it says find the interval where f is increasing and decreasing. So for increasing, what you have to do is determine the sign of the derivative, okay? The derivative. Now, the partition numbers for the derivative are plus or minus 1. So I'll just say minus 1, 1 here. If you pick a number here, I'm testing the derivative. No matter what, the numerator of the derivative is always negative, and the denominator is also, you know, positive. So which means this is always negative, this is always negative, this is always negative. So what does that means? It is increasing nowhere, it's decreasing from negative infinity to negative 1, negative 1 to 1, and 1 to infinity. Everywhere is decreasing in its domain. So do we have any relative extrema? The answer is no, because if we have relative extrema, it should be at a critical number, but there is no critical number. Okay, now the next is, where is this function? Concave up and concave down. So for that, I have to find the second derivative. Again, remember, this is again a quotient, so you have to use a quotient rule. So use quotient rule, then this guy should simplify to 8x times x squared plus 3 divided by x squared minus 1 cubed. So that's how you simplify to. Now, just like the first derivative, if I find the second derivative, the partition numbers are what? Negative 1 and 1. Similarly, and then I have x here to be 0, right? So now, if I pick a number here, the second derivative is negative. If I pick a number here, it's positive. If I pick a number here, it's negative. If I pick a number here, it's positive. So what does that means? It is concave up on the interval negative 1, 0, union 1 to infinity, and concave down on the interval negative infinity to negative 1, union 0, 1. Now, you can see that negative 1 and 1, they are vertical asymptotes, so there is no any tangent line, so it cannot be an inflection point. So the only inflection point would be at 0. So at 0, it changes from concave down, concave up to concave down. And at 0, we have a tangent line, because if you see the derivative at 0, the derivative at 0 is what? Here, I'm plugging the derivative. I'm trying to find if there is any tangent line. The derivative at 0 is negative 4 over 1, which is negative 4. So which means I have a tangent line there. So what that means? Inflection point will be 0, comma f of 0. So if you plug what the value of the function at 0 is, it will be 0. So there's nothing, again, the x and y intersect. So finally, the graph is going to look like, this is what the graph looks like. I have a vertical asymptote. Let me use maybe a different color. And then I have another vertical asymptote, 1, negative 1. And then the horizontal asymptote is y equal to 0. And then I have x and y intercept. Let's now pick another color for graphing. So it says from negative infinity to negative 1, it's decreasing. So it should be something like this. And then from negative 1 to 0, it is decreasing. It's increasing. And then here also, no, I don't think it's increasing, right? So we don't have, yep, it's not increasing, it's always decreasing, sorry. So let me erase that. Oops. It says it's decreasing, so something like this, right? It's decreasing, and then here the graph will be again decreasing, something like this. So this is what the graph. Now you can check that everything is clear. So from negative 1 to 0, it's concave up. Negative 1 to 0, it's concave up. 1 to infinity, it is concave up, right? That's correct. So it says concave down, negative infinity to negative 1, yes. And then from 0 to 1, it's concave down, good. And then if there is a concavity change here, yes, from up to down, and then it's always decreasing. So that will be the graph of the function. Thank you for watching. I'll see you in the next video.